Hello. So today I'll ask Pextra Cortex to help with a typical IT operations task. This is the aging hardware detection and replacement estimation. We are running this demo on Pextra CloudEnvironment version 1.42.1. So we're going to open up the Pextra Cortex chat and we're going to ask it a question. We're going to ask, Hi Cortex, can you check for any aging hardware across our infrastructure and tell me which systems might need replacement soon? So in any large infrastructure, keeping track of hardware aging is critical. Over time, servers and components degrade, leading to performance loss, higher maintenance costs, and potential failures. Our goal is to have Cortex identify aging hardware, assess its health, and provide an estimate for replacement costs. So see now it's asking us if it's okay to proceed with what it wants to do. It wants to run a hardware aging health check across my current organization, which is all the clusters that I have to identify nodes that may need replacement soon. So we're going to approve this and we are going to wait for a response. So here, after only 26 seconds, it's already given us a response. It's telling us what it found. It's saying that there are three nodes in total, and it's telling us the for each node the amount of cores it has, telling us the memory, the storage, and the health signals. And then also after that, it's telling us the aging risk assessment. It's telling us that the CPU generation is old and it can cause lower performance. It's telling us that the DDR3 memory is also old. It's telling us that the RAID or slash storage controller is also old. And it's giving us, after that, it's giving us recommended next steps. It's giving us, you can see there are a few recommended steps it's giving us. We actually don't want to do this. We want to ask it another question, which is which nodes are most critical to replace first? And we will wait for a response. So here it's giving us an answer. It's giving us this answer based on age and hardware lineage. It's giving us that the first server to replace is server one. The second one is server two, and the last one is server three. It's telling us here in the notes why we should replace these in this order. Why server three is the least priority, and why server one is the highest priority. And after that, we want to ask it another question to go deeper into this. Can you estimate replacement costs for these nodes? And now we will wait for a response. So after only 21 seconds, it's given us a rough estimate of how much these will cost. Here it's giving us different scenarios. Here's scenario A, B, and C. Per node, 3 to 5,000. And the 3 node total will be 9 to 15,000. Here's scenario B, per node, 6 to 10,000, and the total for all three, 18 to 30,000. And scenario 3, per node, 12 to 20,000, and all 3 nodes in total would be 36 to 60,000. And it's giving us a few notes here that real quotes depend on the exact CPUs, the RAM amount, the storage type slash quantity, and the NICs. It's also telling us that the prices don't include these things such as OS licenses, hypervisor licenses, data carrier migrations, rack power, cables, on-site installation, or extended warranties. And the last thing it's telling us is that the disk slash smart status and warranty status may affect final costs. So now after this, we are going to ask, um, can you recommend any upgrade options? And now we will wait for a response. So after only 19 seconds, it's already given us a response. You can see it's giving us different options. We have option A, B, and C. We also have option D. It's showing us that what option A is, the pros and the cons. You can see here option B, what it is, the pros and the cons. Option C, what it is, pros and the cons. And option D, you have what it is, the pros and the cons. And over here, after all of that, it's giving us considerations to look at when we are looking at the different options that it's giving us. And now, finally, we're going to ask it one last question. Draft a phase replacement plan, timeline, BOD, BOM, budget for these, and include a health slash smart risk assessment per node. And now we'll wait for a response. So look at that. After only 34 seconds, it's giving us a full plan on what we can do to replace all of these. It's giving us the assumptions that it has. It's giving us the different phases. Here's phase 0, the goals and the deliverables. Here's the node health status. Here's phase 1, the objective, the BOM. Here are just all of these things. Here's phase 2, phase 3, and here's overall budget with all the phases. And here it's giving us optional upgrades, along with the Health Smart risk assessment per node. So as it also gives us the next steps that I can do in order to go into this. So as you can see, Pextra Cortex automatically scanned the environment, detected aging components, prioritized replacements, and generated accurate costs and upgrade recommendations. All of this that he did within just a few minutes and with minimal technical expertise required. This demonstrates how Pextra Cortex significantly reduces time and effort for IT operations, minimizes the need for deep infrastructure expertise, and enhances the overall efficiency and accuracy of hardware lifecycle assessments and replacement cost planning. So I hope this was helpful for you today. Thank you.